Hi, I'm Markus. This is my project, Free Water PFW. So, in the start I asked myself, how can I save people from dying of diseases? How can I help them from dying of no clean water? And why does this happen? How can I make a machine that is sustainable and works like it should and is cheap? And then I brainstormed ideas how this is happening. So in cities, inventions are made to run on electricity, which is a con. So they can't work in a rural area since there's not a lot of electricity there, since it's isolated from cities. So those inventions won't even work. They have to be sustainable. Over 2 billion people each year drink water with low sanitation that might infect you with diseases like polio or diarrhea and is contaminated with feces.
Marcus, it might be better if you kind of stand and then look at the screen.
Okay.
Yeah. Then you can just use the laptop to change slides.
Okay. So, microbiologically contaminated drinking water can transmit diseases such as diarrhea, cholera, dysentery, typhoid, and polio, and it's estimated to cause 485,000 diarrheal deaths each year. Studies illustrates. And then here's a picture of risk also arises with drinking water from pollution of microplastics. And this explains how microplastics might travel around. So, cool. I had to imagine ways how to get like the water so I could save people. So my first thought, let's use a vacuum to suck out the molecules, water molecules, H2O, out of the air. And then my second thought was solar power and a sponge. And that's what I went with. So this is my plan, how I would carry out the whole thing. So this was my original design with mirrors. So the mirrors are supposed to reflect light down to a hole, which were sponges, and it'll reach temperatures of over 100 degrees. So the water, dirty water in this sponge will start evaporating, and then there will be a tube to this box here, which is colder than this one, and when steam gets colder, it starts getting more dense, which eventually becomes water again, clean water. And then there's a collecting tube down here, which sends it through, and then out here, so you can drink it. So this explains how the first box works, and I based it on categories like cheap, accessible, and strong. And I call this the heater because it has a way longer name. So the materials that I would have used if I could would be plastic, mirrors, sponges, tube, hinges, cabinets, glass, and wires. So yeah, here it says how it works, like I just explained. Okay, so the second smaller box is what we now are talking about. The cooler box, I call it the cooler. And it's also judged on the category cheap, accessible, and strong. So the materials used here would be fiberglass fans, solar panel wires, plastic, a collector tube, a tap, and a tube. And then yes, then it says what I explained to you. So I noticed some flaws in my design, so I fixed them. So the mirrors originally was too powerful, basically. Yeah, it would cause a fire hazard for the sponge. The sponge would start burning, and then you don't want to drink that water. And then when it's cloudy, my machine won't work. Then how it's gonna save people? So for my first issue, I decided to rearrange the position of mirrors and did my design like this. So they point down to a hole where there's a piece of glass that spreads the beam out so it's not hitting one part of the sponge. And for my second problem, I have decided to go for something called molten salt technology. It works by taking the heat from the sun, and now the mirrors in this cage, and then they will keep the temperature of the sun and mirrors, and then you can keep it from around an hour or so up to 100 degrees, an hour or more. Yeah. And then I shared it on Seesaw with everybody, and I think it went really well. So this is some of the pictures, like the science cycle, hopefully. And yeah, there's also explanation on Seesaw, so go check it out. And that's it. So thank you for watching. Bye.